Hello everyone, welcome to my channel.
In this video, I'll explain how this agent works. In short, the user types in a question, it goes into this code generation agent, and inside we load the data frame, build prompt with schema, call the LLM, generate Python code, and execute it. From the user point of view, it's just text to chart in one click. So by the end of this video, you will have a working text-to-chart app that you can download and run on your own machine. Understand a simple AI agent for turning natural language into charts. Understand the architecture and design, so you can swap in your own dataset with just a few small changes. You will also understand the pros and cons of the AI agent, and you will develop an AI native mindset. If you're not a developer, you will walk away with a tool where you can query data in plain English and get charts back without waiting for someone to build a new dashboard for you. So if you are ready, let's dive in. As a data scientist, I used to build dashboard and analytics to provide insights for my users, but very often they also want to ask their own questions, since that I didn't hard code into the dashboard. So I built this AI agent to let them use natural language to generate their own charts on top of the same data. So on this dashboard, you see is a analytic dashboard for YouTube videos using this US videos dataset. In the AI agent, you can ask questions like, show the trend of views over time, and click ask. It generates a chart for the total views over a time period based on the data set. Let's try a different questions. Top 10 channels by total likes. So the agent generates the Python code to plot the chart and render the chart in the dashboard immediately. So in this video, I'm going to walk you through how this text-to-chart agent works at high level using Python, Streamlit, and LLM. We'll keep it simple and focus on the idea, not the code line by line. And if you like to try this code yourself, please subscribe, like this video, and check the link in the description. I'll share a starter project so that you can download the code and run it locally on your own machine. So this is a very simple agent. It's basically a single prompt, single call code agent. So at higher level, it received the user query from Streamlit UI, and it combines query with some data context and send everything to large language model. The model generates the Python code, and we execute that code to render chart in Streamlit. So the most important piece here is a prompt we send to the model. It's a single but very detailed prompt. It gives the model context about the dataset, what this table represents. Then it passes in any filters or user options from the UI. And it gives the model the data frame schema or the column names and sometimes example values. We also define a very clear output format. We'll tell the model something like, you already have a pandas data frame in memory. Use plotly to plot the chart. Only output Python code, no explanations. Usually we wrap the generated code in a code block because later we are going to extract the text between those markers and execute it. We also give the model a list of rules. For example, don't read files from disk, don't import random libraries use existing data frame that's already loading memory. So the agent basically knows I have a data frame in memory. I should only use that plus data pandas and plotly to create a chart. So on the Streamlit UI side, the flow likes this. The user types in a question and the app shows the detected column names and they know what they can refer to. And then when they click the button, we'll send the question and the metadata to the code agent. And the code agent generates the Python code and the Python runtime execute Python code in a sandbox using the data frame in memory, pandas, and the plotly tools. And then it creates a chart and output return it to Streamlit UI. And then we see the chart and table on the UI. Now I want to talk a little bit about the pros and cons of this simple code agent approach. First, it's not a multi-agent system. It's not autonomous agent that plans multiple steps or maintains long-term memory. It's just a small focused agent that takes a query and outputs the code. But it definitely have a few nice properties. First is flexibility. The agent is free to decide how to answer this question, which column to use, which chart types make sense, and what transformation to apply to the data. And the second is transparency. The user can always see the generated Python code. They can check whether the logic actually matches their intention. And third is that the context aware, because we pass in metadata and schema of the data frame, including the column names and sometimes the data ranges. The agent understands the real dataset and is less likely to hallucinate random column names. Lastly, it's efficiency. It's a single-shot agent. Each question is answered in one model call, which is fast and relatively cheap for simple charting tasks. And of course, there are also some limitations. Because it's a single shot, it cannot self-correct. So if the first code generation is wrong, it doesn't automatically try again or inspect the error. We don't store any long-term state or long-term memory across the calls. The agent won't remember the previous code generations or previous questions. Every request is stateless and handled from scratch. So even with these limitations, this is a very nice starter agent that you can actually implement in a very short time and start using. So if you like to play with this idea, you can download the code from the link below, run it locally, and then customize the prompt, tweak the rules, or replace with your own dataset. If you enjoy this kind of practical AI project where we build small tools that actually work in work or life, please like this video and subscribe to the channel. And come to join my community where we learn and build AI together. Thanks for watching.